Am I audible? Can you please confirm? Am I audible? Can you please confirm? Dear participants, can you please confirm? Am I audible? Very good evening, dear participants. I welcome you all to this 30 days masterclass series on electric vehicle design. Today is a day 4 power calculations for electric vehicle design. And in addition to that, we will also look into the MATLAB Simulink experiments. Right. So yeah, before enter into the class, I welcome you, Manohar, Deepesh, Chandreshwaran, Dhaneshwaran, Neet, Ajit, Annamalai. Yes, welcome participants. Warm welcome, Shakat, Manga Raju, Ashish, Charan Reddy, Anjali. Very good evening. Am I audible? Narendra Verma, low voice. Okay, till just a second. Give me a second. Let me check. Hello, am I audible now? Now is it okay? Can you confirm? Now is it okay? Yes. Now is it okay? Yeah. Thank you, participants. Thanks for your valuable comment. Now let's start the class. Yes. Thank you, participants. And about the Pantech is educational equipments manufacturing company. From Pantech, you can get lab equipments for powertronics and drives and renewable energies, fuel cell and microcontroller, DSP, VLSI, IoT related trainer kits also we have. And in addition to that, we also support high-end technical training. And our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 10 lakh students. And attendance form will be provided at 8:40 p.m. in the live chat, so you don't worry about it. I will share the attendance form, and after this live, I will make the attendance form in this comment box. So that attendance link will be available till 10:30 p.m. So you don't worry, don't hurry up. Definitely, you can get the attendance form, right? Right. And so in this 30 days master class, so we have covered basics of the vehicle designs, like we have calculated them how much power required to move the vehicle for the specific specifications, right? And again we have discussed about the MATLAB, how to open the MATLAB, how to click on the MATLAB link, and how we can start our design step by step, right? So I hope you understood the basics of the MATLAB. So from today onwards, we will keep on add a lot of experiments to understand the entire electric vehicle concept, right? And after this day 4 class, then from tomorrow onwards, we will discuss about the power electronics. So those who are all not able to understand the PWM, how this PWM can affect our motor control, everything. So if you know the basics of the signal generation, then definitely you can understand those concepts also. Those who are all coming from mechanical background or computer science background, or other than this electrical and electronics background, right? So definitely I'm here to help you to understand all the concepts of the electric vehicle system. Then you can post your questions in this video comment box, and our team is ready to answer your questions, right? And I mean, internship last date is tomorrow is the last day to join the internship. Link is available in this video description box, so you please check and use the coupon code to get your discount. And so today we are going to discuss about motor control. So as of our earlier class discussions, So we have somehow arrived that motor power, right? So now how this motor power can help us to move the vehicle, and what are all the methods are available to connect the motor, everything we will discuss, and how we can understand the motor control concepts, right? And in addition to the drive cycle, so what will be the drive cycle, because the EV system is going to be a variable type of load, right? So variable speed type of load. So in that case, we should understand how the power demand may happen. And finally, we will verify with the MATLAB examples, right? Are you ready to learn these concepts today? Are you ready to learn these concepts today? If you are ready, please make the comment. Please comment in the comment box, ready to learn. If you are ready, please comment in the comment box, ready to learn. If you are ready, please comment in the comment box, ready to learn. Ready to learn. Yes. Thank you, Mr. Deepan. Thank you, Mr. Harshad. Yes. Thank you. If you have any more questions about the previous classes, you can mention here. I will try to give you the answers. Thank you, participants. If you have any more questions about the previous day class, you can ask me. I will clear your doubts. Then we can move ahead. Thank you, participants. For sliding gate, can I use the same concept for the motor sizing? See, actually, that is I'm not sure that exact calculations may happen. Thank you, participants. Which versions of the MATLAB you can use? Any one of the, like a 2019 or 2020 or 2021. Any one of the MATLAB that's useful. Right? Right. So now in the electric vehicle, so this is the power flow diagram of the electric vehicle system. Here we will use the electrical energy, like a battery is the electrical energy. As of our calculations, battery is the electrical energy, and this electric motor drive. So here the drive nothing but the power electronic circuit and then motor is combined. So when you apply a control system for the motor, then the motor will convert electrical energy into the mechanical energy, right? So now if you take our calculators, just a second, I will calculate. So now as per our calculations, so like for example, to keep this one, so we need 18.9 kilowatt is the motor power requirement, right? So now we need 18.9 kilowatt. So in that case, so about 20% higher than this requirements. So we should keep how to choose the motor. So generally it should be 20%, like 1.2 times into 18.9. So this is the exact motor requirements. So 22.6 kilowatt motor we have to keep. So the motor rating for our requirement is 22.68 kilowatt motor we have to keep. So if you keep this 22 kilowatt motor at this point, so now the entire vehicle can move with this help. So now whether are we going to consume the entire 22 kilowatt motor in this EV for entire travel time? No, we won't consume that entire 22 kilowatt motor. So then how we can consume the motor power? Then how we can consume the motor power, right? So let us understand this one. If you take, there are the two type of loads, right? So how you will consume the load? So actually, if you take instantaneous power, sometime it will be like a let us assume the 50 percentage. Sometime you may go 20 percentage. Sometime you may go 100 percentage. Right? So this is called instantaneous power. So let us take it as a dynamic power. So instantaneous power at that particular time, based on particular time, how much power you are going to consume. So how much power? Nothing but see here in this case. So the voltage will be again this case generally voltage and then current is going to be a product of the power, right? So here while you change the PWM, we can change the voltage. We can change the voltage at the same time we can change the control also. So that is the closed loop control mechanism for the motor control. So now if you take this average power, if you average the power, then for the entire travel time, so it will be like a summation of the entire dynamic power. So now how you can understand the average power and then dynamic power. So for that one, the people are using the drive cycle. So in this MATLAB Simulink, you will get a drive cycle. In the day one class, I have shown you some reference cycle and then actual reference speed and then actual speed. Similarly, yes, just a second, I will show you one more graph. So the drive cycle will be used. So this is called a drive cycle. So this is a standard drive cycle. So based on the road conditions and the driver data, they have given us a, drive cycle. So this is the control signal for the PWM input. I will tell you what is the PWM input and what are all the other control mechanisms in this motor control. So just follow the entire class. Right, just to follow the entire class. So this block is available in the MATLAB Simulink to identify the control logic. So before get into this drive cycle, you must know what is the PWM. So in the previous day class, we have developed the sine wave and the triangular waveform, and the comparison of the sine wave and the triangular waveform. We got it as a like a pulse width modulation. That is called the sine pulse width modulation. Right. So anyone, have you finished the assignments yesterday? Have you finished the yesterday assignments? Have you finished the yesterday assignments? Can you please confirm? Have you finished the yesterday assignments? Have you finished the yesterday assignments? Can you please confirm? Because actually only few people has posted your assignments in the FB group. So I am expecting more results. I am expecting more results from your end. I am expecting more results. Why, Mr. Benjamin? Why? What happened to you? So please post your results. Post your results in the FB group. Then only your social profile will increase. Because actually, why I am insisting you to keep on post the results in the FB group in the sense. See, actually, if you involve this activity, so once you finish this 30 days, then after this 30 days, so you will end up with a clear idea about the EV, and also when you recap these results after 1 year or 2 year, then definitely you can again quickly you can recap all the technology. Whenever you are going to the interview, you can easily apply your experience. So for that reason, nowadays the people, everyone are improving their social profile by posting this kind of assignments in the social network. Right? So please submit your assignments in the FB group. So I have given the FB group. So please share your outputs. Right. So now, right. So now, how this motor and conventional vehicle and then IC engine has been connected. So generally there are the different type of hybrid methods are there. In the earlier stage, so the motor that is called the IC engine part, and then electrical part. So this is called series hybrid mechanisms. Series hybrid mechanism. Anyhow, the transmission mechanism will be used to transfer the mechanical power, right? So similarly, the parallel mechanism. So this, I mean what? So IC engine will apply a parallel, I mean separately, and then electrical power will apply a separately. So whenever the driver can take a call to connect how the things need to be connected. Similarly, you can go for the series and parallel hybrid methods also. So first one is the series and the second one is the parallel, and now this is the series and parallel. So here, actually, frankly telling that, I mean by combining this hybrid technology, so you are increasing a lot of complexes. So now the lot of technologies are available. Latest technologies are available to convert as a convert as a a vehicle into the computer. So it will be like a high-end robotic, high-end computer on the wheel, right? So actually, that kind of technologies are available. To understand those concepts, you must know very clear about here, like battery, power converter, and then motor control. So here the power converter will place the will play a controlling methods with the PWM, right? So now are you ready to learn the concepts of the PWM? If you are ready, please comment in the comment box. If you are ready, please comment in the comment box. So now let's move to the power electronics block. So before get into the power electronics, I should give you the PWM. See, right? So actually, this is the yesterday questions. This is the yesterday question. So many people, I mean, a few people has submitted their assignments. I am really happy. Those who are all submitted your assignments, and thank you for your interest. And also those who are all not participated the assignment, so please submit your assignments in the FB group, right? So now let us move to the another type of waveform. Another type of waveform. So this is called a square pulse, right? So the another waveform is the square pulse. So for generating the square pulse, so again just open the library browser. Just open the library browser. So you will get to know about. You will get to know about. Just go to the sources and take a pulse generator block. Take a pulse generator block, right? Just select the component and keep this component in your workspace. Just select the component and keep the component in your workspace. And right. So now we have generated the now we have taken the pulse generator. So this pulse generator will help us to convert to generate a square pulse. So from that square pulse, we can understand how this PWM can start and how the PWM can be used. So this is called the basic PWM methods. So here, the pulse generator will help us to generate a square pulse, right? So this is the time axis, and this is the y-axis, y-axis, and then this is the x-axis. So here we are just developing the square pulse. So this is the square pulse, right? This is the square pulse. So now this period is called on time. This period is called on time, and this period is called off time. So the total period will be turn on and then turn off time. The summation of turn on time and then summation of turn off time is called the total time period. Called total time period, right? So we can call it as a T, right? So here the period nothing but that is called the frequency. So generally the waveform, all the waveform will be mentioned as a frequency, right? So F is equal to 1 by T. F is equal to 1 by T. So now the T is nothing but the time period between the starting time of the period and then end of the pulse, right, on the particular cycle. So now if you take this 1 kilohertz frequency and then 50 percentage duty cycle of the square pulse. So 50 percentage of the pulse. So now let's assume that, so this is the 1 kilohertz. So 1 kilohertz nothing but 1 by time is equal to 1 by f, right? For f is equal to 1 by t. So likewise you can get it. You can calculate the total time period, and the you want to generate a square pulse, then the duty cycle must be 50 percentage. Duty cycle must be 50 percentage. So let us take this graph. So now we are just trying to develop a square pulse. So here the period nothing but 1 by the period nothing but it's a time in seconds. So here you have to convert 1 by here you have to mention the frequency, right? So 1 by f. So here frequency is 1 e power 3, 1 kilohertz. And after that, pulse width. If you keep here the 50 percentage, then the square pulse will be there. Keep a 50%, then you will get a square pulse. Just apply here and just try to understand the square pulse. Just change the layout. Just change the layout. Just give me a second. Yes. So now just try to run this simulation. Here we are getting the square pulse. We are getting the square pulse, right? Second, I will increase the value the graph. Yeah. See here, the 1 kilohertz is the frequency of this square pulse. So exactly 50% is the on time, and then 50% is the off time, right? So 50% is the on time, and then 50% is the off time. So now, if you want to change the duty cycle, so here you have to change the value. So instead of 50 hertz, if you apply at 25 percentage, if you apply 25 percentage, then you will get 25 will be the on time, and the remaining 75% will be the off time. 25% will be the on time, and then remaining 75% will be the off time. So like that you can change the PWM. So now the logic is, so here the output voltage, see for example, if you the input is the 24 voltage, output will be the duty cycle into 24 voltage, right? So now we have keep the 20 d is the 25 percentage, so which means that 0.25 value, right? So the output will be d into 24. So approximately 6 voltage, approximately 6 voltage will be the output voltage. Now you have a choices to change the duty cycle. You change the duty cycle into 0.5 percentage, right? So if you change the value to 0.5 percentage, then output will be d into 24. So exactly you will get a 12 voltage. So by this method we can change the voltage. The logic is how you can change the speed of the motor. I will tell you in the next next experiment. By changing the input to terminal voltage, then we can change the speed. So obviously this is the very basic speed control technique. So now you are in the position to change the output voltage. Now you are in the position to change the output voltage. Theoretically, if you change the duty cycle, you can change the terminal output voltage. Right? Do you have any questions? Are we clear? Are we clear about these concepts? Are we clear about these concepts? Are we clear about the concepts? If you are clear about the PWM, so please comment in the comment box. Please comment in the comment box. Super clear. Please comment in the comment box. Super clear. If you have any more questions, you please ask me. I will try to give you the answers. Yes, thank you, participants. If you have any more questions, you please comment in the comment box. Conversion of analogy to discrete Sampling where we use the multiplexer which is yes, Mr. Puneet. Thank you, participants. Can we use for motor curve? Yeah, see, actually this logic we are going to implement in the motor control. I will tell you how to implement in the motor control. Just engage the class. Just engage the class. Why we are generating square pulse? You must know how to generate the square pulse. You must know how to generate the square pulse because we are going to use this block set in the motor control part. Because we are going to use this block set into the motor control part. When we use a square wave and when we use to triangular waveform. See, actually here all the square wave we will use some logic, and then triangular the sine waveform we will use some logic. So you must know how to generate a square pulse, how to generate a triangular pulse, how to generate a sine pulse, and how you are compare. You must know how to compare all these functions. These are the very basic functionalities. Right. Thank you, participants. So time period, why time period is written in that 1 e power 3. So which means that time period is the function, I mean function of 1 by frequency, right? So the inverse of frequency is the time period. So just now I took a frequency is the 1 kilohertz. So I took that value. Thank you, participants. What is duty cycle? Duty cycle nothing but like a I mean the fraction of on time divided by the total time period. Fraction of on time divided by the total time period. For the three phase, we need 120-degree phase shift. For the three phase, we need 120-degree phase shift. Right. So now let's move to the next topic. So actually, we have covered the basic sine, I mean waveform generation. So here with the waveform, how we can control it. So for controlling the waveform, I mean for the controlling the output voltage, you must know what is the power electronics. So here as of now, see just take this, keep this point in your mind. Power electronics is the application of solid state electronics to control and convert the electrical power, right? So which means that uh, here some logic will be there. Here some logic will be there. So here input we are just applying, right? So input is applying, here we are taking the output, right? So here we will apply a PWM. Here we will apply a PWM. So this logic, right? So this logic will be this logic will be based on the solid state devices. I will tell you what is the solid state devices, and I mean in the next classes and all. So just to keep this in mind, here we are using some electronic circuit to convert the input power to the output power with the help of PWM control. Now you must tell me what is the difference between the basic electronics and the power electronics. Do you have any idea about it? What is the difference between basic electronics or basic analog electronics to the power electronics? Can you just tell me what is the difference between basic electronics and then power electronics? I'm just waiting for your reply. I'm just waiting for your reply. What is the difference between basic electronics and then power electronics? Yes, I'm just waiting for your reply. High voltage in power electronics. Exactly, Mr. Lokeshwara. The basic electronics will handle up to maximum 12 to 24 voltage. The basic electronics will handle up to maximum 12 to 24 voltage. Whereas those electronics, if that particular circuit handles more than the 24 voltage, everything comes under the power electronics, under the power electronics devices, power electronics domain. Now you must know what is the basic components of the power electronics. As we know that a transistor, right? So the transistor, BJT, JFET, and then MOSFET. So these are all the electronic devices, and it's called as a solid state devices. Called as a solid state devices. And how you can break the circuit? Do you know how to break the circuit? If you have any breaker in between the circuit, then you can easily break the circuit. So that's a breaker called as a like a manual breaker, right? If you manually, if you lift the breaker, then the circuit will isolated each other. Similarly, you have another kind of breaker called a mechanical relay. Another kind of relay, another kind of breaker called a mechanical relay. If you apply a control voltage to the relay, then manually the contact will get removed between this line. So that is called mechanical relay. Similarly, electronic relays are available. That is called the solid state electronics. So do you know the diode? So the diode will have a solid state silicon material. When you apply a voltage, automatically that electron flow may happen between that two junctions. So generally, it will be positive and the negative junctions will be there. So if you apply a voltage to the diode, then it will try to connect the anode and the cathode terminal. So that is all we will tell you. I have some animated videos, the classes. I will tell you one by one. So try to engage with the entire class, right? So this information is enough at this moment. And for next 3 days, we are going to discuss in detail about the power electronics. So just keep ready your MATLAB and then computer, so that you can practice the experiments. At least you should practice daily one experiments. At least you should practice daily one experiment, right? Now let's move to the next experiment. Let's move to the next experiment, and let's have a counter design. I will show you one counter design. Then we can go for the motor control, right? So, so how we can count the pulse? So let us take the same square pulse. Just to take the same square pulse, and time period is 10 seconds. So now we have to convert the square pulse into exact 50 percentage, right? Right. So 10 seconds we are going to run this one. So just to take the scope, just to take the scope. So where you will get a scope? So here, just to take the scope, just to connect the scope, right? So if you run this one, you run the scope, you run the simulation. See here, here you can get a square pulses, right? Similarly, you can get a square pulses. So now I'm just going to reduce the time period. So for 1 seconds, one pulse. So for the 1 second, one pulse should generate, right? Just to save the simulation, just to save the simulation, and now you can run the simulation. See here, we are getting the 10 pulses. So this is the pulse 1, and then pulse 2, pulse 3. For the 10 seconds, for 10 seconds, we are generating pulses, right? So we are generating the pulses. So now, how you can measure the motor speed? Do you have any idea about it? Do you have any idea how how you will measure the motor speed? how you will measure the motor speed? Do you have any idea how you will measure the motor speed? So in the motor shaft, you should have you should have a sensor. That sensor will give you the square pulses. So now electronically you have to count the pulses. Electronically you have to count the pulses, right? So the tachometer is the instrument. So that instrument you cannot use in your control algorithm. So you should have a electronic circuit. That electronic circuit generally we will use the optical sensor. So tachometer is the instrument. Tachometer is the instrument. So here you have to use one optical sensor. Generally it is called a speed sensor. So that if you keep the speed sensor in the motor shaft, so the sensor will give you the square pulses. So in the logic, like you have to develop a program in the microcontroller. That controller should measure the speed, number of pulses on particular seconds or particular time or whatever it may be. So for that reason, you need a counter program, right? So now we are going to use the counter logic. So how you can measure the counter? How you can measure the pulse, right? So here take a sum block. Take a sum block. Yes, just to take a sum block and take a sum block and connect here and take a one more graph called memory one. Take a memory block. Yes, just to take this memory block, rotate the block. Yeah, just take this one and connect it here. Now we can measure the number of pulses, right? So actually this will help. Take a display block. Take a display block. So now we are going to just measure the pulses. So how we can measure the pulses and all? You please wait. I will tell you. So you can check it in detail. So and then change the layout. You can easily grab the results, right? Just try to run this one. So it will give you random value. So here we have to change the sample time. So here we have to change the sample time. I will tell you how to change the sample time and all. To just engage the class. Run this. Here I mean it's giving the this program counting some value. So now this is not exact one. So now you have to adjust the sample value. See, generally in the electronic circuit, the ADC will be used to sense the real-time parameter. ADC part, that is analog to digital converter, is used to measure the real-time parameters, because the motor speed is the real-time parameter. Electronically we have to measure the parameter. So in that case the sample and the hold parameter may involve in your algorithm, right? So here the what do you mean by sample? What do you mean by sample? If you take any one continuous signal, continuous signal nothing but this is the continuous signal. This is the continuous signal. Now you should identify this is the one pulse and this is the another pulse and this is the another pulse, right? So if you take a two samples per period, if you take a 2 samples per period, then you can easily identify the logic. If, for example, if you take the sample at this moment and if you take the sample at this moment, right? If you take the sample at this moment and at this moment, then you can easily calculate the pulses. If you keep, if you increase the sample between this within this seconds itself, then it will give you the fault result. So now I am just going to adjust the sample time period. Just adjust the sample time period. How you can adjust the sample time period? So again, just go to the configuration parameter. Just go to the configuration parameter and here change the fixed step. Here change the fixed step. Yes, attendance I will share you just a second. Yes, attendance I have shared here. So please use this attendance. So don't forget to submit your attendance form. Don't forget to submit your attendance form. Yeah. Attendance form I have shared in the chat box. Please submit your attendance form. Right? And here here you have to change the sample time. So actually as per our design, 1 second is the time period, right? 1 second is the time period. If you keep the seconds 0.5 is the sample time, then we can take this is enough to identify the logic. Now we are getting the 31, but by default it's only 10 pulses, right? Here now we are getting the 11. So that is the next pulse also it's going to calculate it. So next pulse also it's going to calculate. So for that case you have to run this simulation for 9.9 seconds. To run this one, then you will get a 10. Here we are getting the exact 10 pulses, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 pulses we are getting. So we are this block will give you the exact 10 value. So by this method, you can develop the logic to measure the speed of the motor in the real time. The real time, right? In the real time, right? Can you just tell me what is the confusion? I will try to answer your question. You just share me the question. I will try to give you the answer. Sample time should be the same as the cycle. No, it's not. Sample time is the I mean what you need the parameter to calculate it, right? So that value that should be less than the time period. Attendance link is available at the top of the chat. Attendance link is available at the top of the chat. Sample time must be less than the period. I mean one cycle period, one cycle of the time. Yeah. You please answer. You please mention your question. I will try to give you the answer. FB link I will share you in the group. FB link I will share in the group. Thank you, Mr. Verma. So you please share your questions. I will try to give you the answers. Can you please share me your questions? I will try to give you the answer. Right. So now let's move to the another experiment. Now let's move to the another experiment. Yes. So here just open the WhatsApp group. I will share you by email. Actually, in the email, I'm keep on sharing the FB group as well as the WhatsApp group. Just open our email and then get everything. Right. So here one more experiment is there called DC motor identifications. To show sample time explanation on the scope. See here, the sample time is if you take a simulation. So this is the one software. That software will have some code in the backend, right? So here we are applying continuous signals. Here we are applying continuous signals. Now the logic has developed to identify the signals. Here if you take this graph, so this is the one period. So the one time period is for the 1 seconds. Now you should have our task is you have to count the pulses. You have to count the pulses. How many pulses are here? How many pulses are here? For the for 10 seconds, only 10 pulses are there. So now you have to develop a logic to count the pulse. Now you have a logic to count the pulse, right? So here one pulse will come and it will add. Initially the memory block will be 0. Initially the memory block will be 0. So 0 plus 1, 1, right? 0 plus 1, 1. So initially it will be 1, and after that, so this data will be stored in this memory. After that, this data will stored in the memory. So the next sample, after the next sample, what it will come? So here if you open it, 1 plus 1, 2, right? 1 plus 1, 2. I hope you understood the concept. And next and the next interval, see here, here the 1 will be there, and here this moment the sample value, if you take the sample is for the entire period, will be 0. So here the 2 will remain continue, and after that 2 plus 1, right? So this 2 will be stored in the memory, and here the 1 will be there, and then 2 plus 1, 3, and the process will continue till the end of the period, and finally you will get a 10. So because we are having 10 pulses, yes, here we are having 10 pulses, right? I hope you understood the concepts. So the memory block is to store the previous data. Memory block is to store the previous data. Memory block is to store the previous data. Store the previous data. As we have a triangular pulses, why we need rectangular pulses? See, actually, each and every pulses are the separate logic to implement in the PWM controller. So for the implementing the motor control, we will use the motor PWM logics. Is there any possibility to start internship in this area, PV and then wind hybrid? Yes, we have a renewable energy internship. Renewable energy internship. Triangular pulses, we will use some logic. For some instance we will use a triangular pulse, and for some instance we will use a rectangular pulses. So that's why we should know all the logics. That's why we should know all the logics. Any more questions? Any more questions? We have to select a sample time such that the first sample is in the positive cycle and next. Exactly. Not a negative, it will be the 0. The Vijayanti, it will be 0. How speed is related to the PWM generator? See here the PWM generator is not going to be the speed. The speed is nothing but the speed. If you want to measure the motor speed, you should add the sensor and the shaft. The sensor output will be the square pulse, right? So now you are in the position to measure the speed, number of pulses. So this counter logic we can use it in the motor speed controller, sorry, motor speed estimator. How to provide the dead band in the PWM generator. So for that one, you just take a two pulse generator and two pulse generator. So in the two pulse generator, you can use AND logic. You have to use AND logic. In that AND logic, we can generate a pulse dead band. Mr. Benjamin, I will give you the power electronic concepts from the tomorrow. So if you check this agenda, we check this agenda. So tomorrow is the introduction to power electronics and then power converter design and then power converter logics, everything we have scheduled. So please try to engage with the class. Actually, since you all from the other than the electrical, you cannot. I mean, this 45 minutes is not enough to transfer all the concepts. Just engage with the entire class. You just ask the questions related to the topic. Memory block used to hold the previous data. Memory block is to hold the used to hold the previous data. Yes, thank you participants. Memory block is used to hold the previous data. What will be when the pulse goes negative? So negative, of course, negative pulses will reduce the count. Number of sample is equal to number of revolutions of the motor shaft. No, you cannot take that accent. See, actually here the sample is used to take a data. See, actually we are getting the signal from the sensor. We are getting the signal from the sensor. In the microcontroller should read the sensor. So to read the sensor, you need a sample data. You need a sample data. Mr. Baba, you are taking the different way. So please understand, sample is the programming. In the programming, we will use the sample data to check the value, whether is it high or low or whatever it may be. Try to understand the logic. How to, Mr. Sai Pavan, take my number. You please call me after this live. Why do we count the pulses? See, this is a counter pulse. I mean, this is an example how to, if you have a question like how to count the pulse. So in that case, this use this logic to count the pulse. Yeah, Mr. Akshay, we are going to develop a logics. We are going to develop a closed loop applications. Does it count for the negative? You have to identify the logic to count the negative pulses also. Akash, yes, we have a project closed loop application also we have scheduled. Any more doubt? Any more doubt? If you have any more doubt, you please ask me. And more thing in the library, the DC motor. I will show you the demo for the motor. Go to the events, test power electronics, fundamental blocks, machine. Here we can have a DC motor. So this DC motor, we have to develop a PWM and then output input voltage, and by that time you will use these logics. By that time you will use these logics to control the motor, right? Control the motor. Benjamin, use any other latest softwares, latest versions. Then only you can use that one. Can use different pulses in the one model. Yeah, you can use any different pulses. Actually, everything you have to develop a logic. Everything you have to develop a logic. How to measure the motor speed? Actually, in the simulation we have a model. Whereas in the practical case, you have to use the any one sensor like a speed sensor. We have to use. After this live, you can call me Mr. Akshay, Akash. If you have any more questions, you please call. Ask me. I will try to give you the answers. We can, in short form, say about the complete concepts of today's class. Somebody getting little confused. See here. In the So here we have to apply a motor, right? So here we have to apply a motor because then only we can get a mechanical power. So the motor needs a control model. So the motor needs a control model. So here the pulse width, that is called the PWM, needs to be applied in the power electronic circuit. So I will tell you what is the power electronic circuit in the next class, right? So the PWM needs to be there. So how you can generate a PWM? So there are different methods. Very first one is you can use the square pulses, or else you can use the sine wave and the triangular waveform. From that you can apply a PWM, right? And once if you develop the PWM and then the motor will rotate it. So here you should measure the motor speed, right? So here you should measure the motor speed. So this motor speed should return to the PWM. Then only the motor will work in the stabilized manner. Otherwise, you cannot get a stability. So now you should know how to generate a PWM, how to measure the speed, how to measure the speed. So this is the two different concepts today we have discussed. Right? If you have any more questions, I hope you understood the unit. How to calculate the body weight of the vehicle? See here, body weight. You have to select the weight. You have to select the weight. How controller count pulses for the measuring the motor speed? How controller count the pulses? Actually, automatically it won't count the pulse. You have to develop a control. You have to develop a program. So in the program, you have to use this logic. Mr. Puneet, yes, it is possible. It is possible. If we have any more questions, Mr. Gopal, yes, BLDC program, BLDC motor control, we have included in this topic. Calculate body weight of the vehicle. I have answered. Any more questions? BLDC is included. How to download the new versions of the MATLAB? So just go to the Google and search. Go to the Google, search MATLAB free trial, then you can download it. Search. Just to open the YouTube. Open the YouTube and search MATLAB Simulink. MATLAB installation. MATLAB installation. Then you will get a video. So just follow the video. You just follow the video. You will get a complete idea. I will share you the link in the comment box. You please take a note. I will share you in the comment box. Just do this. How can you use suitable motor for vehicle? In the motor control part, we will select it. The motor control part, we will select it. Yes, thank you, Mr. Khalid. Puneet, you can call me after this live. I will try to give you the answers. Apurva Garg, yes, you have such kind of program, so you can call me. I will help you. Attendance link is in top of the chat. Attendance link is in the top of the chat. Any mode square waveform used to generate with sum of memory. Yes, exactly, Mr. Junit. Yes, just follow this video. You can download the MATLAB. Just follow the video. Just follow the video. You can download it. Yes, so the internship is the last date, 24th. Tomorrow is the last date. Use the coupon code. Description link is available in the description box, so you can check it. I will share the internship registration link. Those who are all interested in the internship, you can join here. For special for your custom requirement, you can call me. I will help you. You can call me. I will help you. So this is my WhatsApp number. You can ask me your questions. This is my WhatsApp number. You can ask me your questions. Those who are all having clear, doubt, you can call me. I will give you the solutions. I will give you the solutions. If you have any more questions, you can ask me. Else, you can leave the class. Mr. Squib, the 10th second next pulse will be started. So that's why we are stopping the simulation at 9.9 seconds. Yes. If you have any more questions, you can ask me. I will try to give you the answers. during driving, exact square triangular pulses won't generate. Then is there any fine-tune methods? See, there is no any direct methods. You have to identify. You have to form a number of loops in the control algorithm. So then only we can develop a logic. We will use a design. We will design buck boost converter for high voltages. Yeah, we will use the buck boost converter. Any pulses you can use it, Mr. Junit. Take my WhatsApp number. You can ask me. I will try to give you the answers. Thank you, participants. Thanks for your valuable time. We will meet you in the next class. Thank you. Thank you once again.